Mercury, an enigmatic planet, despite being closest to the Sun, is still the least known to us. Often overshadowed by its neighbors, it's a world of mystery waiting to be revealed. What if Mercury isn't what we thought it was? Recent discoveries indicate that this planet is more dynamic and complex than anyone imagined. From shrinking landscapes to mysterious blue troughs, Mercury is challenging everything we know about it. Imagine a planet rushing around the Sun at breakneck speed, a world so close to the solar furnace that it's hard to even get close to it. Few missions have dared to visit this elusive world, and those that have discovered only glimpses of its secrets. However, a new mission, Baby Colombo, is on its way, and it promises to unlock mysteries that have puzzled scientists for decades. Already, we're seeing things that defy explanation. Strange features, unexpected phenomena, and hints of a story yet to be told. Mercury's X-ray auroras, its changing topography, and its hidden interior all suggest that the planet is far more intriguing than we ever thought. Prepare to see Mercury in a whole new light. It's not just a planet. It's a mystery at the edge of the Sun. Mercury, the innermost planet, orbits closest to the Sun. It's the smallest planet, slightly larger than our moon, and takes only 88 Earth days to complete one orbit. Because of its proximity to the Sun, Mercury experiences temperature extremes that range from scorching highs of 800 degrees Fahrenheit to icy lows of minus 290 degrees Fahrenheit overnight. Its surface is a mosaic of craters, ridges, and plains. Unlike other planets, it has no significant atmosphere to protect it from meteoroids, resulting in a landscape heavily riddled with craters, reminiscent of our moon. One of the most striking features is the Calor's Basin, one of the largest impact craters in the solar system. This massive basin, about 960 miles in diameter, was formed by a colossal impact early in Mercury's history. Another unique aspect of Mercury is its unusually large core, which makes up about 85% of the planet's radius. This iron-rich core generates a magnetic field, but it's only 1% as strong as Earth's. Despite its weak magnetic field, Mercury has magnetic poles and a magnetosphere that interacts with the solar wind, creating phenomena such as the recently discovered X-ray auroras. Exploring Mercury presents significant challenges. Mercury's proximity to the Sun means that spacecraft must withstand intense solar radiation and heating. In addition, Mercury's fast orbit requires precise, energy-intensive maneuvers to enter its orbit. In 1973, NASA launched Mariner 10, the first spacecraft to visit Mercury. Mariner 10 utilized the gravitational assistance of Venus, allowing it to make 3 flybys of Mercury between 1974 and 1975. These flybys produced the first close-up images of the planet's surface, showing the heavily cratered terrain and complex geologic features. However, the mission captured only 45% of the planet's surface, leaving much unexplored. Decades later, the Messenger spacecraft, launched by NASA in 2004, became the first spacecraft to orbit Mercury. After a challenging journey that included flybys of Earth, Venus, and Mercury itself, the spacecraft entered its target orbit in 2011. During its 4-year mission, Messenger made more than 4,000 revolutions around the planet, collecting a wealth of data on Mercury's surface composition and magnetic field. Messenger showed Mercury's surface in unprecedented detail, mapping almost the entire planet. It revealed volcanic plains, evidence of past tectonic activity, and gave a glimpse of the planet's thin exosphere. One of the most surprising discoveries was the presence of water ice in permanently shadowed craters at Mercury's poles, even though the planet is close to the Sun. Building on the successes of Mariner 10 and Messenger, the Baby Colombo mission represents a significant step forward in Mercury exploration. The mission is a joint effort between the European Space Agency and the Japan Aerospace Exploration Agency. Launched in 2018, Baby Colombo should provide comprehensive data on the geology, atmosphere, magnetosphere, and history of Mercury. Baby Colombo consists of 2 main spacecraft, ESA's Mercury Planetary Orbiter and JAXA's Mercury Magnetospheric Orbiter, also known as MEO. Together, these spacecraft will study the planet from different perspectives, offering holistic views of its evolution and environment. The mission's journey to Mercury will be long and complex, involving many gravity-assist maneuvers. Colombo has already made flybys of Earth in 2020 and Venus in 2020 and 2021. It will make 6 flybys of Mercury before entering orbit in December 2025. These flybys are critical to adjust the spacecraft's trajectory and slow it down enough to be captured by Mercury's gravity. The goals of Colombo are ambitious. The mission should map the planet's surface in high resolution, analyze its composition, and study the magnetic field and magnetosphere. It will also study the planet's exosphere and search for evidence of past volcanic and tectonic activity. Since its launch in 2018, Colombo has been steadily approaching Mercury, making a series of flybys that have already yielded significant results. These preliminary observations provide new insights into Mercury's complex geology and dynamic environment. One of the key contributions of the mission was the detailed mapping of Mercury's surface. The spacecraft discovered many previously unknown craters, each telling a different story of the planet's turbulent history. Among them are impact basins that show the scars of ancient collisions, shedding light on the early chaotic period of the solar system. One of the mission's most intriguing discoveries is the detection of X-ray auroras around the planet. Unlike visible terrestrial auroras, Mercury's auroras are detected in the X-ray spectrum. This phenomenon, first hinted at by the Messenger mission, is now confirmed by Colombo. These X-ray auroras are caused by the interaction between Mercury's magnetic field and the solar wind, a stream of charged particles emitted by the sun. When these particles collide with the planet's surface, they generate X-rays, causing a faint but scientifically valuable glow. Mercury, an enigmatic planet, despite being closest to the sun, is still the least known to us. Often overshadowed by its neighbors, it's a world of mystery waiting to be revealed. What if Mercury isn't what we thought it was? Recent discoveries indicate that this planet is more dynamic and complex than anyone imagined. From shrinking landscapes to mysterious blue troughs, Mercury is challenging everything we know about it. Imagine a planet rushing around the sun at breakneck speed, a world so close to the solar furnace that it's hard to even get close to it. Few missions have dared to visit this elusive world, and those that have discovered only glimpses of its secrets. However, a new mission, Colombo, is on its way, and it promises to unlock mysteries that have puzzled scientists for decades. Already, we're seeing things that defy explanation. Strange features, unexpected phenomena, and hints of a story yet to be told. Mercury's X-ray auroras, its changing topography, and its hidden interior all suggest that the planet is far more intriguing than we ever thought. Prepare to see Mercury in a whole new light. It's not just a planet. It's a mystery at the edge of the sun. Mercury, the innermost planet, orbits closest to the sun. It's the smallest planet, slightly larger than our moon, and takes only 88 Earth days to complete one orbit. Because of its proximity to the sun, Mercury experiences temperature extremes that range from scorching highs of 800 degrees Fahrenheit to an icy low of minus 290 degrees Fahrenheit overnight. Its surface is a mosaic of craters, ridges, and plains. Unlike other planets, it has no significant atmosphere to protect it from meteoroids, resulting in a landscape heavily riddled with craters and reminiscent of our moon. One of the most striking features is the Caloris Basin, one of the largest impact craters in the solar system. This massive basin, about 960 miles in diameter, was formed by a colossal impact early in Mercury's history. Another unique aspect of Mercury is its unusually large core, which makes up about 85% of the planet's radius. This iron-rich core generates a magnetic field, but it's only 1% as strong as Earth's. Despite its weak magnetic field, Mercury has magnetic poles and a magnetosphere that interacts with the solar wind, creating phenomena such as the recently discovered X-ray auroras. Exploring Mercury presents significant challenges. Mercury's proximity to the sun means that spacecraft must withstand intense solar radiation and heating. In addition, Mercury's fast orbit requires precise and energy-intensive maneuvers to enter its orbit. In 1973, NASA launched Mariner 10, the first spacecraft to visit Mercury. Mariner 10 utilized the gravitational assistance of Venus, allowing it to make 3 flybys of Mercury between 1974 and 1975. These flybys produced the first close-up images of the planet's surface, showing the planet's heavily cratered terrain and complex geologic features. The spacecraft's images showed a world similar to our moon, with vast plains and numerous impact craters. However, the mission captured only 45% of the planet's surface, leaving much unexplored. Despite the limited coverage, the mission data laid the groundwork for future research. Decades later, the Messenger spacecraft, launched by NASA in 2004, became the first spacecraft to orbit Mercury. After a challenging journey that included flybys of Earth, Venus, and Mercury itself, the spacecraft entered its target orbit in 2011. During its 4-year mission, Messenger made more than 4,000 revolutions around the planet, collecting a wealth of data on the planet's surface composition and magnetic field. Messenger showed Mercury's surface in unprecedented detail, mapping almost the entire planet. It revealed volcanic plains, evidence of past tectonic activity, and gave a glimpse of the planet's thin exosphere. One of the most surprising discoveries was the presence of water ice in permanently shadowed craters at Mercury's poles, even though the planet is close to the Sun. Building on the successes of Mariner 10 and Messenger, the Bepi-Colombo mission represents a significant step forward in Mercury exploration. The mission is a joint effort between the European Space Agency and the Japan Aerospace Exploration Agency. Launched in 2018, Bepi-Colombo should provide comprehensive data on the geology, atmosphere, magnetosphere, and history of Mercury. Bepi-Colombo consists of 2 main spacecraft, ESA's Mercury Planetary Orbiter and JAXA's Mercury Magnetospheric Orbiter, also known as MEO. Together, these spacecraft will study the planet from different perspectives, offering holistic views of its evolution and environment. The mission's journey to Mercury will be long and complex, involving many gravity-assist maneuvers. Bepi-Colombo has already made flybys of Earth in 2020 and Venus in 2020 and 2021. It will make 6 flybys of Mercury before entering orbit in December 2025. These flybys are critical to adjust the spacecraft's trajectory and slow it down enough to be captured by Mercury's gravity. The goals of Bepi-Colombo are ambitious. The mission should map the planet's surface in high resolution, analyze its composition, and study the magnetic field and magnetosphere. It will also study the planet's exosphere and search for evidence of past volcanic and tectonic activity. By comparing data from both orbiters, scientists hope to gain new insights into the formation and evolution of Mercury, as well as its mysterious magnetic field. Since its launch in 2018, Bepi-Colombo has been steadily approaching Mercury, making a series of flybys that have already yielded significant results. These preliminary observations provide new insights into Mercury's complex geology and dynamic environment. One of the key contributions of the mission was the detailed mapping of Mercury's surface. The spacecraft discovered many previously unknown craters, each telling a different story of the planet's turbulent history. Among them are impact basins that show the scars of ancient collisions, shedding light on the early chaotic period of the solar system. One of the mission's most intriguing discoveries is the detection of X-ray auroras around the planet. Unlike visible terrestrial auroras, Mercury's auroras are detected in the X-ray spectrum. This phenomenon was first hinted at by the Messenger mission and is now confirmed by Bepi-Colombo. These X-ray auroras are caused by the interaction between Mercury's magnetic field and the solar wind, a stream of charged particles emitted by the sun. When these particles collide with the planet's surface, they generate X-rays, causing a faint but scientifically valuable glow. This discovery not only confirms the presence of a magnetosphere, but also provides insight into the nature of Mercury's magnetic field and its interaction with the solar wind. Another important recent discovery was confirmation that Mercury continues to shrink. High-resolution images have revealed features, such as lobate scarps and wrinkle ridges, which are formed by the compression of the planet's crust as its core cools and hardens. These results build on observations made by the MESSENGER mission and provide clearer evidence of Mercury's ongoing geologic activity. The planet's compression has caused its radius to shrink by several kilometers since its formation, creating stress cracks on the surface that manifest themselves as ridges and cliffs. Bepi-Colombo, in turn, has identified several regions where this contraction is most obvious, providing a unique opportunity to study planetary geology in real time. These regions reveal not only Mercury's cooling history, but also its current state, giving scientists clues about the planet's internal structure and thermal evolution. At first glance, Mercury's heavily cratered surface resembles that of our Moon. Both bodies are riddled with impact craters, indicating a long history of collisions with asteroids and comets. However, a closer look reveals significant differences. Mercury's craters are often interspersed with ridges and fault scars, which are less common on the Moon. These scars are indicative of Mercury's compression, a process not observed on the Moon. Today, you'll learn about that, as well as Neptune's strange rings, what makes it so blue, and also what is now known about its famous satellite, Triton. Neptune is an ice giant, about 4 times wider than Earth. It has a radius of about 15,300 miles and a volume of 15 trillion m³, which means that Neptune is 58 times larger than Earth in volume. The planet is composed mostly of water, methane, and ammonia. Like the other ice and gas giants in our system, Neptune has no solid surface. Its atmosphere extends deep into the planet, to the mantle, which is composed of methane and ammonia ice and a rocky core. Nevertheless, scientists believe that the ice giant could theoretically have an internal hot ocean. But how can a planet sustain such an ocean, since it's so far from the sun? It would take sunlight 4 hours to reach the giant's surface. Neptune's average atmospheric temperature is minus 360 degrees Fahrenheit, making it one of the coldest objects in the solar system. In addition, according to recent research, most of Neptune cooled from 2003 to 2018, despite warming near the South Pole from 2018 to 2020, likely due to seasonal changes in atmospheric chemistry. The reason for the likely formation of the ocean inside the ice giant remains unsolved. However, scientists suggest that this strangeness can be explained by internal heating, heat released due to gravitational compression or gravitational interaction between Neptune and one of its satellites, Triton. On the other hand, researchers Sloan Viktorovich and Andrew Ingersoll believe that the probability of oceans on Neptune, due to its heat, is very low, only 15%. At this time, according to scientists' calculations, only in a billion years will the chance of an ocean there increase to 40% after the giant cools down. Another explanation for the huge internal energy could be Neptune's collision with some cosmic object, because Neptune is the only planet that emits nearly 3 times as much energy as it receives from the Sun. This is also confirmed by the unusual 28 degrees tilt axis, almost as much as on Earth. Because of this, Neptune also experiences seasons similar to ours, but on Neptune, one season lasts about 40 years. 1 year for Neptune is 165 Earth years, yet one day on the ice giant takes 16 hours. This rapid rotation of the planet creates super powerful wind, which we'll talk about a little later. Neptune's atmosphere is 80% hydrogen. It also contains 19% helium and about 1% of other gases, including methane. By the way, Neptune's blue color is caused precisely by methane clouds in the upper layers of the atmosphere. Methane molecules can absorb solar shortwave radiation, reflecting the blue color. However, the nearest planet to Neptune, Uranus, also contains a similar distribution of gases, but unlike Neptune, the color is pale blue. Dr. Patrick Irwin of Oxford University suggests that this color difference may be due to the thickness of methane fog. Thus, the atmospheres of both planets have several aerosol layers. The bottom deep layer consists of a mixture of hydrogen sulfide ice. It's because of this layer that some areas, closer to the poles for example, appear darker on Neptune. The second layer is probably just what affects the colors of the planets. It's a layer of haze particles in which methane ice probably forms. The ice then precipitates as a rain of methane snow. Since Neptune's atmosphere is much more active than that of Uranus, Neptune forms this snow more efficiently, so its second aerosol layer is thinner. It is precisely the lower density that creates Neptune's rich blue color. The last, third atmospheric layer also forms large particles of methane ice and is, in fact, an extension of the second layer. In addition to its intense color, Neptune is also characterized by dark and white patches all over its surface. All of these spots are storms, resulting from the planet's very rapid axial rotation. Neptune is the windiest planet in the system. Wind currents there can reach 1,200 miles per hour, which is almost 4 times stronger than on Jupiter. However, the ice giant has one similarity with Jupiter: a huge storm. The name of this vortex is simple enough: the Big Dark Spot. The Earth-sized cyclone, orbiting at 500 miles per hour, was first detected by the Voyager 2 spacecraft in 1989. However, in 1994, another telescope, the Hubble, noticed the spot had disappeared and a small new spot appeared in the northern hemisphere. So, unlike the 300-year-old cyclone on Jupiter, Neptune's large-scale vortices only exist for 2 to 6 years. In 2018, Hubble detected another new spot, similar to the one discovered in 1989. The formation of these storms is still unknown, but scientists suggest they originate deep in the atmosphere, forming over several years. These storms still have something to show scientists. The new 2018 spot began drifting southward the following year, where it would have disappeared. However, unexpectedly for researchers, the storm turned around and began moving back north. What's more, a small one probably separated from the big spot. NASA scientists believe the small vortex may be part of the process of breaking up the big storm, which has never been observed before. Such cyclones in previous observations have been accompanied by white methane clouds called scooters because of their speed of motion greater than that of the big spot. They probably form over vortices, where gases freeze into ice crystals. The lack of clouds, the researchers say, may help in understanding the formation of patches on Neptune and similar ice giants. Like other gas giants, Neptune has another feature: a ring system. In 2022, the James Webb Space Telescope took a near-infrared image of the icy giant, showing its faint rings and satellites. The last image of Neptune's rings was taken more than 30 years ago by Voyager 2. In Webb's new photo, about 5 rings can be seen. All rings are named after astronomers who have contributed to the study of Neptune. The closest and most loose ring is called Halley. It consists of about 40% to 70% dust and is 26,000 miles, with a radial width of 1,240 miles. The second ring, Laurier, is much brighter but much narrower, with a width of a little over 62 miles. The next ring is the widest of all. This is the Lasso ring, 2,485 miles wide. The percentage of dust there is very small, ranging from 20% to 40%. The fourth, Arago ring, is hard to see. It is one of the smallest rings, with a radius of 35,540 miles, and it's on the edge of the Lasso ring, probably because of its low dust content. It is hardly noticeable. The last, Adam's ring, has an orbital radius of approximately 39,724 miles. Moreover, Adam's is only 35 kilometers wide, making it the narrowest ring of Neptune. But what makes this ring stand out are its arcs. The arcs are mysterious, bright segments of dust around the perimeter of the ring. Each of Adam's arcs has a name: freedom, brotherhood, courage, and equality. Interestingly, they are not static at all. These arcs, especially brotherhood and equality, exchange their material and change their size. Why these arcs formed is still unknown, but researcher M.K. Deer suggests that the cause may be the collapse of a parent companion or other object within the Roche limit. In addition to the rings, Webb also recorded 7 of Neptune's 14 satellites. All of the ice giant's moons are divided into regular and irregular. Webb captured 6 ordinary intercept satellites. Some of these satellites, like Despina and Galatea, form Neptune's rings, playing the role of shepherds for dust. However, definitely, the most interesting thing in Webb's image is the most distant bright satellite, Triton. In the photo, Triton looks like a star because it glows much more than Neptune. The strange glow is because the satellite is almost completely covered by nitrogen ice and therefore reflects about 70% of all sunlight that falls on its surface. Triton is Neptune's largest satellite. It is larger even than Pluto, with a diameter of 1,680 miles, which can be equated to 99.7% of the mass of all Neptune's moons. It is also the coldest geologically active object in the entire solar system, with its surface temperature reaching minus 391 degrees Fahrenheit, just because of its light-reflecting icy surface. Like any of the moons of the ice giant, Triton experiences tidal locking, meaning that only one side of it is turned toward the planet. However, its retrograde orbit sets it apart from other satellites, which is unusual and unique to all other satellites in our system. That means that Triton has an inclined orbit, which causes it to move in the opposite direction to Neptune. Also, because of this orbit, its poles and equator alternately face the sun. But what could have caused such an unusual orbital tilt? Most likely, Triton never formed with Neptune. Scientists believe that Triton originally evolved in the Kuiper Belt, but at some point, it was able to be captured by an ice giant. And it's assumed that Triton could hypothetically move around another object. Therefore, the captured Triton slowed down, which prevented it from colliding with Neptune and moving toward Neptune. The satellite could also destroy other moons. Neptune has very few satellites compared to, for example, Jupiter, around which there are almost 70 objects. There probably could have been more, and they would have been larger, had not Triton been captured by the giant's gravitational pull. Triton's features don't end there. If you look closely at pictures taken back in 1989 by Voyager 2, you can discern the satellite's unusual mosaic surface, modeled with plumes. According to the analysis of the craters by scientists, their surface could be from 10 million to 100 million years old, and in some places, the smooth surface on the manifestation of cryovolcanism. Therefore, scientists believe that the moon may have a subsurface ocean. The plumes also probably hint at this, and also depict a depression similar to a lake basin. Despite its low temperature, Triton probably retains a lot of ammonia beneath its surface, which slows the freezing of the water. On the other hand, plumes may appear due to heating by sunlight, causing nitrogen to compress beneath Triton's icy surface until the nitrogen escapes. At this point, proving that the satellite could be an oceanic world is very difficult. In addition, solar heating probably forms the moon's thin nitrogen atmosphere. However, the possibility of life developing there, as on presumably Enceladus, is too early to tell. Given that Triton was part of the Kuiper Belt, does this mean that Neptune can influence its objects? The Kuiper Belt is the boundary of our solar system, also the comet's source. The belt extends from Neptune, 30 by about 20. The belt is predominantly composed of small objects like asteroids and tens of thousands of more large objects, including dwarf planets like Pluto. Were it not for the gravitational influence of an ice giant, it's likely that a planet could have formed from the Kuiper Belt. In addition, have noticed that some objects in the belt, including Pluto, are in long-range resonance with Neptune. Usually, such objects plant tessile can only temporarily come into resonance with a stable fixed in one place planet. Therefore, scientists suggest that it's likely that Neptune may have migrated from the inner regions of the solar system, meaning that it may have originally formed close to the sun. Thus, the migration of the ice giant was probably able to keep many Kuiper Belt objects within the solar system, when without resonances, gravitational effects could have pushed them outside the system and even in our direction. Neptune definitely has many unexplored mysteries. At this point, we don't know, for example, the exact composition of Neptune's interior or in general how ice giants are formed. So we have to wait for future scientific expeditions that will help us better understand the chemistry of these worlds and unravel many of the mysteries that interest us. For centuries, Venus has been a planet of intrigue and mystery. Known as Earth's twin, it shines in our night sky, yet remains one of the most hostile places in our solar system. Back in 2021, the ESA JAXA Colombo mission made a fleeting visit to Venus. However, it was in April of this year that a reanalysis of the data revealed unexpected findings. There were oxygen and carbon ions coming out of the planet's upper atmosphere. These heavy ions, which are normally slow and difficult to move, have been found accelerating at unexpected speeds. Scientists still can't figure out what forces are behind this phenomenon. Is it an electrostatic wind, or perhaps centrifugal processes have intervened? Venus has long been an object of exploration. Early missions like Mariner 2 confirmed the absence of a magnetic field, and 4 gave us our first glimpse of its thick, toxic atmosphere. Pioneer Venus Orbiter and Venus Express mapped previously unknown regions, but many questions remain. So, how did Colombo allow a more detailed picture to emerge? How did Venus lose its water, and why is its atmosphere so different from Earth's? And most importantly, could we ever survive on Venus? Today, we learn about the harsh reality and the taunting possibilities of setting up a home with our mysterious neighbor. Venus's atmosphere is a complex and fascinating study, composed mostly of carbon dioxide and sulfuric acid clouds. It starkly contrasts the life-sustaining air we breathe on Earth. At the surface, the pressure is 90 times the Earth's pressure, and temperatures reach 869 degrees Fahrenheit. Now, this incredible heat is the result of the greenhouse effect, trapping solar energy in the dense, opaque atmosphere. Our understanding of this hostile environment began with early missions like Mariner 2, which first confirmed extreme surface temperatures. The Venera 4 spacecraft made deep measurements, revealing a dense carbon dioxide atmosphere and the presence of sulfuric acid clouds. Pioneer Venus Orbiter mapped the upper atmosphere, showing the dynamism of Venus's weather systems and the presence of thunderstorms. And then came Colombo. During flybys, the spacecraft penetrated previously unexplored regions of Venus' magnetosphere. Its instruments detected positively charged oxygen and carbon ions being carried away from the upper atmosphere. These findings were unprecedented because heavy ions like these are usually slow-moving and difficult to dislodge. The output of these ions testifies to the complex interaction between the solar wind and the atmosphere of Venus. Unlike Earth, which has a strong intrinsic magnetic field, Venus only has a weak-induced magnetosphere created by the interaction of the solar wind with its atmosphere. This makes Venus more susceptible to atmospheric destruction by solar particles. Now, for the most startling fact, a comparative study of water loss by Earth and Venus was conducted. Both planets, according to scientists, started with the same amount of water. However, Venus's proximity to the Sun and the lack of a protective magnetic field allowed solar radiation to break down the water molecules in its atmosphere. Hydrogen, being the lighter element, escaped into space, while oxygen remained, contributing to the dense carbon dioxide atmosphere we see today. In contrast, Earth's strong magnetic field has protected its atmosphere, preventing significant water loss and enabling the development of life. The striking difference emphasizes the importance of magnetic fields for planetary habitability. Understanding the atmospheric mysteries of Venus not only provides a glimpse into its past, but also serves as kind of a precautionary measure for us here on Earth. The Venus Express mission, launched in 2006, built on those results and used the Space Plasma and Energetic Atoms Analyzer to study ion emissions in detail. It measured the absolute number of hydrogen, helium, and oxygen ions escaping, providing crucial insights into atmospheric loss processes. In August of 2021, Colombo, a joint mission of ESA and JAXA, made its second flyby of Venus. This spacecraft penetrated previously unexplored regions of Venus's induced magnetosphere. The mass spectral analyzer and ion analyzer detected cold oxygen and carbon ions escaping from the atmosphere. These ions were detected at a distance of about 6 planetary radii in a previously unexplored region. Among the departing ions were O positive and C positive, the latter being the first to be seen escaping from Venus's atmosphere. This indicates a complex interaction between the solar wind and the induced magnetosphere of Venus. Unlike Earth, which has a strong magnetic field of its own, Venus has only an induced magnetosphere, formed by the interaction of the solar wind with its atmosphere. The induced magnetic field is comet-shaped, creating a magnetosphere in which solar wind particles are slowed down and heated. Bepi-Colombo's observations of the ion ejection mechanisms in this region have provided new insights into the processes that are inexorably destroying Venus's atmosphere. Understanding these mechanisms is critical to understanding the evolution of Venus's atmosphere, in particular, the process of losing its initial water concentration. The quest to understand Venus involves not only studying its hostile environment, but also looking for the potential for life in the most unexpected places. Even in Venus's harsh atmosphere, scientists are searching for the fundamental components of life. High-tech experiments aim to study Venus's atmosphere in search of evidence of life-supporting molecules. The discovery of phosphine gas in the upper atmosphere of Venus in 2020 has sparked intense interest on Earth. Phosphine is associated with biological processes, leading scientists to wonder whether similar processes could occur on Venus. However, the harsh conditions on Venus complicate this search. Because of the extremely high surface temperatures and immense atmospheric pressure, any potential life forms must be incredibly survivable. Despite these difficulties, the search continues. NASA's upcoming missions, Da Vinci and Veritas, aim to delve deeper into the atmosphere and surface of Venus. The Da Vinci mission will focus on measuring atmospheric gases, including noble gases and other elements, from the top of the atmosphere to the surface. These data will help scientists build new climate models and study the chemical composition of the atmosphere in more detail. The Da Vinci lander will provide unprecedented insight into the composition of the atmosphere and possibly detect molecules that may be precursors to life. These measurements will be critical to understanding the habitability potential of Venus and other similar exoplanets. The Veritas mission, on the other hand, will create high-resolution maps of Venus's surface. By studying the planet's geology and topography, scientists hope to discover signs of past volcanic activity and water flows, which are important clues to understanding Venus's history and its potential to harbor life. This detailed study of Venus's surface and atmosphere helps astrobiologists improve their models of planetary habitability. Venus provides an instructive example. Despite its similarities to Earth, its environment has taken a radically different path. Understanding these divergent evolutionary paths can help us in our search for habitable worlds beyond our solar system. Venus and Earth, often referred to as sister planets, have striking similarities in size, mass, and composition. However, their environmental and atmospheric conditions could not be more different. Venus's atmosphere consists mainly of carbon dioxide and nitrogen, with clouds of sulfuric acid creating a dense, toxic blanket. Earth's atmosphere, in contrast, is composed of nitrogen and oxygen, supporting a variety of life forms. Atmospheric pressure on Venus is 90 times higher than Earth's, which is equivalent to being underwater at a depth of 1,000 yards. The greenhouse effect is extreme here. Solar radiation penetrates through dense clouds, heating the surface, but a dense atmosphere of carbon dioxide traps this heat, resulting in surface temperatures of around 869 degrees Fahrenheit. On Earth, on the other hand, the greenhouse effect maintains temperatures suitable for life, but in a delicate balance. There are also several fundamental differences between the two planets. In addition to their proximity to the Sun, Earth has a relatively fast rotation period of 24 hours and a stable axial tilt, which promotes even heat distribution and supports seasonal changes. Venus, on the other hand, rotates slowly in the opposite direction of most planets in the solar system, with a rotation period of 243 Earth days. This slow rotation and lack of significant axial tilt result in minimal temperature fluctuations between day and night. The slow retrograde rotation contributes to the planet's extreme weather patterns in thick, superrotating cloud layers that circle the planet every 4 Earth days. These clouds reflect a significant amount of sunlight, giving Venus a bright appearance, but also trapping a tremendous amount of heat. Geologically, both planets have volcanic landscapes. However, whereas on Earth, tectonic activity recycles carbon and supports a diverse climate, Venus lacks this form of tectonic recycling, contributing to its unique, inhospitable environment. The surface of Venus is dominated by vast volcanic plains and high-altitude regions. The lack of tectonic plates on Venus means that heat is stored beneath the crust until it's released by catastrophic volcanic events, reshaping vast areas of the planet. The presence and loss of water are crucial factors in the different evolutionary paths of these planets. Measurements of the ratio of deuterium to hydrogen in Venus's atmosphere indicate that the planet once had a significant amount of water. The high ratio suggests that the lighter hydrogen was lost over time, while the heavier deuterium remained, indicating a historical loss of water. The different evolutionary paths of Venus and Earth give rise to the realization that the planet may be habitable. Venus's proximity to the Sun probably created a greenhouse effect that vaporized all the oceans and led to its current inhospitable state. Earth, which is at a moderate distance from the Sun and has a protected magnetic field, has retained liquid water and a stable climate favorable to life. As we enter a new era of space exploration, several ambitious missions are about to reveal more of its secrets. ESA's Envision mission, already scheduled for launch in 2031, is designed to provide a comprehensive understanding of Venus from its core to its outer atmosphere. Envision will build on the discoveries of previous missions, such as Venus Express, which have hinted at volcanic activity, and will offer a detailed understanding of Venus's geological and atmospheric processes. Envision will carry an extensive suite of instruments designed for a comprehensive study of the planet. Synthetic aperture radar will map the surface at resolutions of up to 10 meters, revealing details about surface texture and geological activity. Its subsurface radar sounder will penetrate up to a mile below the surface, searching for underground structures and layers. 3 spectrometers, VenSpec-U, VenSpec-H, and VenSpec-M, will analyze trace gases, look for volcanic gas plumes, and map surface composition. The Gravity Radiological Experiment will use radio waves to study the planet's internal structure and atmospheric properties. Envision will help unravel how geologic processes, such as volcanism and tectonics, affect the planet's atmosphere and climate. This integrated approach will provide critical data to answer long-standing questions about Venus's past and present geologic activity and the dynamics of its atmosphere. India's Chakrayan mission, led by the Indian Space Research Organization, is another important addition to the exploration of the planet. Planned for launch in the early 2030s, the probe will study the atmosphere and surface of Venus using a suite of advanced instruments. Instruments will be installed on board to analyze cloud layers, atmospheric composition, and features of the planet's surface using infrared and ultraviolet cameras. The spacecraft will study the dynamics of Venus's dense cloud cover and the interaction of the atmosphere with the surface. One of Chakrayan's main goals is to understand the sulfur cycle on Venus, which plays a crucial role in the chemistry of its atmosphere. By studying the distribution of sulfur compounds and their interactions with other elements, Chakrayan will contribute to our understanding of the complex atmospheric processes on this yellow planet. These missions have the potential to revolutionize our understanding of Venus. By combining data from Envision, Chakrayan, Da Vinci, and Veritas, scientists will have a complete picture of the geologic and atmospheric evolution of Venus. These missions will provide crucial data on volcanic and tectonic activity, atmospheric composition, and surface interactions, helping to build a detailed picture of the planet's past, present, and even future. Data from these missions will also help us understand planetary habitability and the conditions necessary for life. By studying Venus, we'll be able to improve models of atmospheric and geologic processes, which will improve our ability to identify habitable environments on exoplanets. Looking to the future, the ultimate goal of Venus exploration is to pave the way for future human missions. Although the planet's extreme conditions pose significant challenges, advances in technology and a better understanding of the environment may one day make planetary exploration possible. Future missions could include robotic explorers capable of withstanding the harsh conditions of Venus's surface, and then developing habitats that would protect humans from the intense heat and pressure. These habitats would then be equipped with advanced life support systems, allowing for longer stays on the planet and more in-depth scientific research. Exploring Venus is not just about exploring our nearest neighboring planet. It's about pushing the boundaries of what's possible in space exploration. By overcoming the challenges of Venus, we'll be able to develop the technologies and strategies that are needed to explore other extreme environments in our solar system and beyond. Imagine that you're in another world, where the sky burns with a crimson hue, and the landscape consists of endless stretches of rust-colored plains and towering volcanoes. This is Mars, our neighbor in the solar system, a planet that's captivated our imagination for centuries. But what do we really know about this alien world? From ancient astronomers charting the night sky to modern Mars rovers traversing its rocky terrain, Mars has always been a source of mystery and fascination. Its elusive nature has sparked countless debates and inspired many science fiction stories. But what if we told you that the real story of Mars is even more intriguing than any fiction? On this journey, we're going to delve into the never-before-seen, unseen realm of Mars, which is beyond the reach of our human eyes. We're going to explore Mars as we have never seen it before, through the prism of ultraviolet images. Today, we take a journey with NASA's MAVEN spacecraft, which has been studying Mars from orbit since 2014. We'll learn how it peeks into the Martian atmosphere, capturing images with wavelengths beyond the visible spectrum and revealing secrets that have been hidden for ages. Our journey to discover Mars did not begin with high-tech spacecraft and advanced imaging technology. It began centuries ago with curious minds and rudimentary telescopes. Ancient astronomers were the first to chart the path of Mars across the night sky, noting its distinctive reddish hue. But it wasn't until the invention of the telescope in the 17th century that we first saw the red planet. Early observers noticed polar ice caps and dark areas, which they mistook for seas and continents. As telescopes improved, so did our understanding of Mars. The 19th century brought us the infamous channels of Mars, a misinterpretation of surface features that gave rise to wild theories about Martian civilizations. Let's go back to the 20th century, to the dawn of the space age. Mars became a prime target for exploration. The first successful flyby was NASA's Mariner 4 spacecraft in 1965, when it sent the first up-close images of Mars. Since then, an entire fleet of orbiters, landers, and rovers from various space agencies have taken on the role of exploring Mars. Every mission, every technological leap has brought us closer to understanding Mars. One of the most significant advances in Mars exploration has been the development of imaging technology. From grainy black and white photos of Mariner missions, we've moved on to high-resolution color panoramas, infrared, and even ultraviolet images. Ultraviolet imaging, in particular, has opened a new window on Mars. It allows us to see what our eyes cannot: the complex interactions between the Martian atmosphere and solar radiation. This brings us to the MAVEN mission and its ultraviolet imaging spectrograph, known as IUVS, an instrument that's revolutionized our understanding of Mars. So, we've already established that in the grand race of Mars exploration, one mission stands out for its unique approach to unlocking the secrets of the red planet. NASA's MAVEN, launched in 2013, the Mars Atmosphere and Volatile Evolution, or MAVEN project, had a single purpose: to study the upper atmosphere of Mars. Unlike rovers that explore the Martian surface, MAVEN revolves around the planet, closely examining the thin gas veil that covers Mars. Since 2014, MAVEN has been diligently observing the Martian atmosphere, focusing on its interactions with the Sun and the solar wind. These interactions are key to understanding how Mars lost much of its atmosphere over time, transforming from a warm and humid world to the cold, barren planet that we see today. At the heart of the MAVEN mission is a remarkable instrument, the Imaging Ultraviolet Spectrograph, or IUVS. This device doesn't just photograph Mars. It captures invisible ultraviolet light, which is invisible to our eyes. In the context of Mars, ultraviolet light is particularly important for studying the planet's atmosphere. When ultraviolet light from the sun enters the Martian atmosphere, it interacts with the gases there, causing them to glow in the ultraviolet spectrum. The IUVS measures wavelengths from 110 to 340 nanometers, well outside the visible spectrum. This is akin to discovering a new dimension of observation, giving us access to an area of information previously inaccessible. But how do we make sense of this invisible light? How can we translate it into something we can understand? The answer lies in the magic of color, a process known as image formation in false colors. Different wavelengths of ultraviolet radiation are assigned colors within the visible spectrum when displayed in artificial colors. In the case of IUVS, 3 specific ultraviolet wavelength ranges are represented by red, green, and blue, the primary colors of light. The shortest wavelengths, about 110 nanometers, are represented by blue. Mid-range wavelengths, about 180 nanometers, are represented by green, and the longest, up to 340 nanometers, are red. By assigning colors to these wavelengths, we can create images that reveal complex details of the Martian atmosphere. But it's not just about color. The brightness of each color in the image corresponds to the intensity of the ultraviolet light. Brighter areas indicate higher intensities, which means a higher concentration of the gas element the IUVS is observing. By combining these colors and brightness levels, IUVS creates a comprehensive picture of the Martian atmosphere in ultraviolet light. It's a bit like painting, but instead of oil or watercolor, we use light of different wavelengths and intensities. These images are not just beautiful, they're also incredibly informative. They show us the distribution of various gases in the Martian atmosphere, the effect of solar radiation, and even the effect of dust storms on atmospheric loss. Through the IUVS lens, we see Mars in a whole new light and get closer to answering the age-old question: what happened to Mars' atmosphere? The MAVEN mission has provided us with truly stunning images of Mars taken in ultraviolet light. These images, taken at different points in Mars's orbit around the Sun, offer a unique perspective on the red planet and its changing seasons. The images, taken by MAVEN at different times of the year, show dramatic changes in the Martian atmosphere. They show how the distribution of gases, such as carbon dioxide and ozone, changes with the seasons, similar to the changing colors of leaves on Earth. This first image was taken in July of 2022, during the summer season in the southern hemisphere. This occurred when Mars is closest to the Sun. The tilt of the planet's axis of rotation causes summer in the southern hemisphere, similar to the change of seasons on Earth. In this image, we see the Chryse Basin, one of the deepest craters of Mars, filled with an atmospheric haze depicted in pale pink. The deep canyons of Valles Marineris are filled with clouds colored tan. The South Polar ice cap, highlighted by a white spot below, is shrinking due to the relative warmth of summer. This second image was taken in January 2023, after Mars had passed the furthest point of its orbit from the Sun. This image captures the northern hemisphere of Mars, where rapidly changing seasons cause an abundance of white clouds. The deep canyons of the Valles Marineris can be seen, highlighted in tan in the lower left corner, along with many craters. Ozone, which is shown in magenta in this UV image, was formed during the cold polar nights of the northern winter. It's worth noting that the imagery produced by the orbiter provides valuable information about the atmosphere of Mars and its interaction with solar radiation. Different colors represent different elements and compounds in the atmosphere, and their distribution gives us an idea of the Martian climate and weather conditions. For example, the purple areas in the image represent ozone in the atmosphere of Mars. The white and blue areas represent clouds or haze in the Martian sky. The planet's surface appears brown or green, depending on how the images have been optimized to enhance contrast and detail. These images also show the effects of solar radiation on the Martian atmosphere. Bright spots in the images indicate areas where the atmosphere responds strongly to solar radiation, indicating the atmospheric loss rate. In addition, MAVEN images have given us a unique perspective on Martian dust storms. These storms, which can engulf the entire planet, significantly impact the atmosphere. MAVEN images show how dust particles rise into the upper atmosphere, affecting their composition and behavior. As we marvel at the stunning ultraviolet images of Mars and the wealth of information they provide, it's interesting to think about what the future holds for Mars exploration. The MAVEN mission has already greatly advanced our understanding of the Martian atmosphere and its interaction with solar radiation. But this is only the beginning. Data and images from MAVEN will continue to be analyzed and interpreted, eventually leading to new discoveries. Looking even further into the future, we can imagine a time when humans will set foot on Mars. The knowledge gained from the MAVEN mission and others will be crucial in preparing for this monumental step. The question of what it will take to establish a human presence on Mars is a topic we've discussed before, shedding light on the challenges and opportunities that lie ahead. As we continue to explore Mars, we can expect the development of even more advanced imaging technologies, which could reveal even more details about Mars, from its subsurface structure to the composition of the tiniest dust particles. The path to understanding Mars is long and difficult, but with each new mission and each new discovery, we get closer to unlocking the mysteries of the red planet. And who knows, maybe one day we'll be able to see Mars, not only in ultraviolet light, but also with our own eyes from its surface.